Quiz 6 is going to be all about learning our additional derivative rules. And the one we're working on this problem here, question 1, is we're going to be using the product rule to find the derivative of this equation they give us here. So f of x equals x minus 5 times x plus 4. So anytime we have something other than a bunch of stuff being added and subtracted, we're going to have another rule to follow. And so whenever we look down at our page and if you see two chunks being multiplied like this, that's when you're going to need to run the product rule. That's going to be your primary rule. And so the product rule saying that I use goes f g prime plus g f prime. So we label that first chunk F and that second chunk G, and then I go ahead and break those out into little bite-sized pieces. So my F piece is my X minus 5, my G piece is my X plus 4, and then now I need to go find a G prime and an F prime, which is just a way of saying find the derivative of F, and then find the derivative of G individually. So coming in and looking at just F right now is when we're going to run into just using the power rule. So really the product rule is a fancy way of breaking everything down into the power rule. And so the power rule just says bring the power down and then subtract 1 from the power. So there's an unwritten 1 on our power on that x right there. So we bring that 1 down. 1 times the 1 in front gets us 1. And then subtracting 1 from the power gets us x to the 0. Anything to the 0 power is always just 1. So we don't need to write that. And then the derivative of a constant, the derivative of -5 is also 0. So that goes away as well. Moving on to G to find our G prime, we've got that unwritten 1 in our power there, so bringing that power down, we get 1 times 1 gets us 1, and then x to the 0 power again, so that's just going to get us a 1. And then the derivative of a constant gets us 0. Now we have all the pieces we need to finally just go construct our product rule that we're trying to put together. So our f prime of x is going to equal, following the product rule, it says first go grab f, so we grab that f piece, which is x minus 5. Then go grab your g prime, so g prime is 1. Then we've got a plus, and then go grab the g piece, which is our x plus 4. And then go grab your f prime, which in this situation is 1. And then the way they want their answer is just a little weird. They're looking for you to they have this piece and this piece set up, and they're looking for you to really just plug in your G prime and your F prime, and that's how you'll end up with an answer that looks like this one. Part B here on this problem is going to say find the derivative by expanding the product first. So then down below they're going to have another box and they're going to want you to fill this in. And how they want you to fill it in is they really just want you to go ahead and multiply these two pieces together. So a lot of people refer to this as the FOIL process. Really it's just distribution. So that's what they mean by expand. So we'll start by expanding this. We take x times x gets us x squared. X times 4 gets us a plus 4x. -5 times x gets us a -5x, and then -5 times 4 is going to get us a -20. And so we'll just clean that up. Not ready to take the derivative yet. Just clean this up. Combine our like terms. We end up with x squared, and then 4x minus 5x gets us -1x and -20. And so that's what you'll want to enter into that first box. And then it'll ask you about the derivative. And so the second part is now just saying take the derivative of that equation that you just created. So using that power rule, just bringing the 2 down, x, subtracting 1 from the power gets us x to the first. And then on the next piece, we end up with bringing that power down. 1 times -1 gets us -1. X to the 0 is just a 1, so that drops off. And then the derivative of a constant is just 0. And so that'll be what they want in the last box. So again, they want you to expand it. And then once that you expand it, they want you to take the derivative of that using your power rule.